Every American schoolchild is taught the legend of the War of the Currents. We are told the story of a bitter personal rivalry between the world's most celebrated inventor, Thomas Edison, and a brilliant, eccentric immigrant named Nikola Tesla. We are told that Edison championed direct current, while Tesla championed alternating current, and that after a long battle of patents, propaganda, and public demonstrations, Tesla's superior technology won out and powered the modern world. It is framed as a corporate war, a battle of business models, or a debate over electrical engineering. There is only one problem with that story. It misses the fundamental reason why Edison failed and Tesla succeeded. Thomas Edison was not just an inventor. He was an empire builder, a ruthless businessman, and a man backed by the greatest financial magnates on Wall Street. He had unlimited money, massive laboratories, scores of talented engineers, and the entire weight of American industrial power behind him. Yet, despite all his power and genius, Thomas Edison was completely, hopelessly blind to the true nature of energy. Edison was looking at electricity through a 19th-century mechanical mindset. He looked at a wire and saw a pipe. He looked at electricity and saw water flowing through that pipe. Nikola Tesla looked at the exact same wire and saw something no one else on Earth could comprehend. He saw an invisible, mathematical universe of rotating forces. Tesla saw a secret hidden within the laws of nature that Thomas Edison, for all his genius, was fundamentally incapable of understanding. And what Tesla saw in a quiet park in Budapest didn't just win a business war, it created the modern, electrified world. To understand what Tesla saw that Edison missed, you first have to understand the massive breaking point that the world reached in the late 1880s. Thomas Edison had lit up New York City with his direct current system, and the world hailed him as a wizard. But Edison's electrical grid was facing a catastrophic physical wall. Direct current flows in only one direction, like water pushing steadily through a garden hose. Because of basic thermodynamics and electrical resistance, direct current loses immense amounts of energy as heat as it travels down a copper wire. To keep the lights from dimming to a faint red glow, Edison's DC power stations could only transmit electricity about 1 mile in any direction. Think about what that meant. To power a single modern city, you would need a dirty, coal-burning power plant on almost every single street corner. Millions of heavy, thick copper cables, some as thick as a human arm, had to be strung over roofs and under streets. In major cities, the sky was literally blacked out by thick webs of Edison's electrical wiring. Beyond the cities, rural America was doomed to absolute darkness. It was physically impossible for Edison's technology to send electricity across countryside, across rivers, or over mountains. Edison saw this problem, but his mind was trapped in the physical world. His only solution was to build more power plants, burn more coal, and make the copper wires thicker. When young engineers suggested that alternating current might be the answer, Edison dismissed them with contempt. To Edison, alternating current was insane. Because AC continuously changes direction, pumping back and forth dozens of times a second, Edison viewed it as wildly unstable, uncontrollable, and lethal. He believed that trying to use AC to run a motor was like trying to drive a car by violently slamming the engine from forward to reverse 60 times every second. It would shake itself to pieces. Edison was locked in a physical, mechanical world. If he couldn't touch it, pump it, or build a mechanical gear for it, he didn't believe it could work. Then came Nikola Tesla. Tesla was born during a lightning storm in Croatia, and his mind operated unlike any other human being in history. Tesla did not need physical laboratories to build prototypes. He suffered from intense visual hallucinations, capable of projecting hyper-realistic, three-dimensional working machines inside his own mind. He could build a motor in his imagination, let it run for weeks, measure the wear on its internal parts, and adjust its dimensions down to a fraction of a millimeter without ever touching a piece of real metal. In 1882, while walking through a park in Budapest reciting poetry with a friend, Tesla looked up at the setting sun and had a sudden, transcendent revelation. He didn't see electricity as water in a pipe. He didn't see it as mechanical pressure. Tesla looked at the universe and saw waves. He realized that if you run two or more alternating currents out of phase with each other through a ring of copper coils, you don't get violent, shaking chaos. You create a smooth, invisible, perfectly balanced, rotating magnetic field in the empty space between the coils. It was an idea of breathtaking mathematical elegance. In Edison's world, to make an electric motor turn, you had to physically touch a spinning rotor with carbon brushes, creating friction, sparks, fire hazards, and constant mechanical wear. Tesla realized that with a rotating magnetic field, you didn't need to touch the rotor at all. The invisible magnetic field would drag the rotor around through thin air, turning electrical energy into mechanical motion with zero physical contact, zero friction, and zero sparks. Tesla had discovered how to create a magnetic tornado in empty space and harness its power to drive the industrial world. When Tesla moved to America in 1884, he went straight to Thomas Edison's laboratory, carrying a letter of recommendation from Edison's European manager that read, "I know two great men, and you are one of them. The other is this young man." Tesla stood before Edison and explained his vision of the rotating magnetic field and multi-phase alternating current. He tried to show Edison that AC electricity could be stepped up to extraordinarily high voltages with a simple transformer, sent over hundreds of miles of razor-thin wire with almost zero energy loss, and then stepped down safely to light homes and turn motors. Edison looked at the young immigrant and scoffed. He told Tesla that his ideas were theoretical garbage, that alternating current was a dangerous fantasy, and that America would only ever run on direct current. Edison couldn't see the rotating magnetic field because it couldn't be drawn like a simple plumbing schematic. Edison lacked the theoretical physics and higher mathematics background required to visualize invisible field dynamics. He was an empiricist who relied on trial and error, testing thousands of physical materials until something worked. Tesla was a theoretical visionary who solved the fundamental physics before striking a single match. Frustrated and broke, Tesla walked away from Edison. He was so poor that for a time he survived by digging ditches for nickel-a-day wages on the very streets of New York where Edison's workers were laying heavy DC cables. But Tesla's vision was too powerful to remain buried in a ditch. George Westinghouse, a brilliant industrialist who understood the power of scale, recognized Tesla's genius immediately. Westinghouse bought Tesla's patents, gave him a fortune in stock, and joined him to challenge Edison's empire. Panicked by the threat to his financial monopoly, Thomas Edison launched one of the dark, desperate smear campaigns in industrial history. Because Edison could not defeat Tesla's mathematics, he attempted to conquer the public's mind through fear. Edison's team began publicly electrocuting stray animals, cats, dogs, and even an elephant, using alternating current to convince the American public that Tesla's system was deadly. Edison secretly funded the invention of the electric chair, insisting that it be powered by Westinghouse's AC generators, hoping the public would associate Tesla's technology with execution and death. Edison called the electric chair "getting Westinghoused." It was a terrifying, grotesque media spectacle. But while Edison was busy killing animals on stage to scare city dwellers, Tesla and Westinghouse were quietly preparing a demonstration that would make Edison's entire infrastructure look like a relic of the Stone Age. In 1893, the World's Columbian Exposition opened in Chicago. It was designed to celebrate 400 years of progress, and it was the first World's Fair to be powered by electricity. Edison's company bid over $1 million to light the fair using direct current. Westinghouse and Tesla stepped in and offered to light the entire fair for less than half that price using multi-phase alternating current. On the night of May 1, 1893, President Grover Cleveland pressed a golden button. In a fraction of a second, over 100,000 glowing incandescent lamps burst into life across the fairgrounds, turning the night into day. White palaces, grand fountains, and massive arcades were illuminated by a brilliant, humming, magical grid of light, powered by Tesla's generators. 27 million visitors from around the globe walked through the Chicago World's Fair and stared in awe at the White City. The debate was over. The public saw that Tesla's system was not a death machine. It was the future of light and human civilization. Right after the fair, Tesla delivered the ultimate knockout blow. For decades, engineers had stared at Niagara Falls, a roaring torrent of millions of gallons of water crashing over cliffs every minute, wishing they could harness its raw, kinetic force to power industry. Edison's engineers had analyzed Niagara Falls and concluded it was useless. Because direct current could only travel 1 mile, a power plant at Niagara Falls would only be able to light up the small, empty woods immediately surrounding the falls. Tesla saw something entirely different. Using his multi-phase alternating current system, Tesla designed the Niagara Falls Power Project. In 1896, the giant turbines began to turn. The mechanical energy of the falling water was converted into high-voltage alternating current, shot down thin wires across 26 miles of wilderness, and delivered straight into the factories and streetcars of Buffalo, New York. It was the birth of the modern power grid. For the first time in human history, massive amounts of energy were generated in a single, clean, remote location and distributed across an entire region to light up millions of lives. Edison's investors realized they had backed the wrong horse. They forced Edison out of his own company, stripped his name off the building, and merged it into General Electric, switching their entire manufacturing line over to Tesla's alternating current patents. So, what did Nikola Tesla see that everyone else missed, and that Thomas Edison never did? Edison saw electricity as a commodity, a physical product to be manufactured in local neighborhood shops and pumped down thick copper tubes to paying customers. He saw a world bound by physical, mechanical friction, local geography, and heavy copper. Tesla saw that energy was not a physical commodity, but an invisible, universal wave. He understood that light, magnetism, and electricity were all part of a single, continuous harmonic frequency. He realized that you didn't need to force the universe to move with brute mechanical strength. You simply had to understand its natural field geometry and let it rotate on its own. Look around your room right now. Every single power outlet in your wall is delivering electricity generated by Tesla's multi-phase alternating current system. The power operating your computer, running your refrigerator, and charging your phone was likely generated miles away at a hydro dam, a wind farm, or a nuclear plant, traveling to you through thin wires at thousands of volts before stepping down smoothly to enter your home. Thomas Edison gave the world the light bulb, but it was Nikola Tesla who saw the invisible rotating waves of nature, conquered distance, and gave humanity the grid that lights up the dark side of planet Earth.